So we were doing some problems involving distribution. I want to do a few more problems before I talk about um, random vector and joint distribution function. Okay, so this is a plan for today. So these are let me do this following problem. So what is that? Mhm. Uh, Let f be the distribution function of random variable x. So find the distribution function of y. So there are several subdivisions. I will just do only one or two of them. Y is equal to, yeah, so let us say square root of x. It's all given in the book, I think. This is equal b, y equals sin x. C, y equals g inverse of x, where g is a continuous monotone function. Strictly increasing function. Okay. All right. So how to compute f of y? So subdivision A, f of y of t is equal to, write the definition. This is probability y less than or equal to t. And what is y? This is same thing as saying probability. Yeah. So y is equal to square root of x. Okay, so you should understand this properly. X is, so this is aside. So x is from omega to uh, real numbers. Yeah, we'll assume that x takes values in r plus. Okay, so r greater than or equal to 0. So that you may be able to write the square root of x. So assume that. Okay. So this means that, yeah, so square root of x is less than or equal to t. And of course, this is 0 if t is less than or equal to 0. And otherwise, well, this is otherwise saying the same thing as x is less than or equal to t square. Yeah, so this would be wrong if, I mean, so first of all, it doesn't even make sense if x takes negative values. What is y is equal to square root of x? So that's a problem already. Okay, so assuming that x bigger than or equal to 0, x takes values bigger than or equal to 0, then x is less than or equal to square root of t, is equivalent implies that x is equivalent to x being less than or equal to t square, and this is, yeah. So uh, you can write here f of fx of t square. So t is bigger than or equal to 0 and is 0 otherwise. Sorry, I changed the order in which thing is written up. Okay, so that's it. It is wrong to just, okay, you may be tempted to write fx of t square and put a full stop here, but because t square anyway is positive, but t square is positive even if t is less than 0, so better write this condition and this condition also explicitly. Okay, I'll do one more problem, but maybe not discuss the other subdivision. There are some more problems in the book. Every section has an exercise, a set of exercises. So please try as many exercises as you can. Okay, so here y is equal to sine x. Yeah, so just to understand, so omega 2 here, uh, this is your x, and then you just compose it with the sine function, and you go here, and this is your y. Okay, this is your y. All right. So now, once you write like this, things will become clear. What is fy of t? Is
Sir.
yes.
Sorry, sir. In the previous question, where did you get the values from? Like 0 if t is less than or equal to 0 and
Yeah,
if
because you see, first of all, what is the so I x takes values where in bigger than or equal to 0, right? If x is okay, so suppose let us just say for definiteness sake t equal to -5. Huh? What is square root of x? When is square root of x less than or equal to -5? It never happens. No, square root always means positive square root. And you can only take square root of a number which is bigger than or equal to 0. So just to make sense of this, I'm saying x takes value. So here we should clarify x is bigger than or equal to 0. I write it briefly like this. The more correct reason is, correct way to write it is that it takes range inside here. Okay. So you square root of whatever number, if x, so this is a very common confusion even in schools. Many people make mistakes. So what is square root of 25? Square root of 25 is 5, not plus minus 5. You understand that? The moment you write square root of 5, it always means positive square root. Yeah.
okay.
Okay. So that means that if I write like this, and then I put a negative number here, there is no such thing. I mean, this set will be empty. Mind you, this is an abbreviation for a set. Do you recognize that? I've been
Yes.
saying it. Yeah.
Yeah.
So, yeah. So square root x less than or equal to -5 will be an empty set.
Yes,
And
sir. Yeah.
yeah, I should perhaps exclude 0 here. That you can really object because it could so turn out. Yeah, t less than 0. This is 0. And this is the case if t is bigger than or equal to 0. So here I had been careful. The next step. So this is same thing as saying fx of t square. Yes. Again, you have to say if t is bigger than or equal to 0. For example, if t is -5, then fx of t square will be fx of 25. But that's not the probability that this is less than or equal to -5. It should be 0 because moment t is less than 0, the probability is 0. Okay?
Yes, sir.
I hope it's clear.
Yes, sir. Thank you.
Okay. Yeah. So now let us do this problem. I will be okay. So this is same thing as probability saying sin x is less than or equal to t. Okay. So you may but sin x takes values where to where. So this takes values only in this range minus y minus 1 to plus 1, but of course this is containing real numbers. And you are supposed to, but this one has domain equal to fy, has domain equal to whole of real numbers. Okay. So t is allowed to be any real number. Okay. So of course this is equal to mt if mod t is strictly bigger than 1. Do you understand this? Sorry, probability of the empty set, which is of course 0. So this is equal to 0 if mod t is bigger than 1.
So shouldn't
Okay.
it be t smaller than minus 1 instead of mod t greater than 1? Because if we have t equal to 1, then sine of x could be smaller than 1. Like,
Sorry. Absolutely, you are right. I should be careful. This is observed what I wrote. Yeah, thank you. So, sure. Yeah. This is t strictly less than minus 1. So, t strictly less than minus 1. Absolutely, because you have less than or equal to t here. Yeah. Okay, so good. Thanks for pointing out the error. So, this is what I meant. Yeah, because okay, fine. So therefore now you worry about, and also you can say probability of, let us get rid of this also, this sorry, fy of, I wanted to say fy, by the same reasoning, fy of this is equal to probability of sin t sin x uh, less than or equal to t. This is probability of the whole space, which is equal to 1 if t is strictly bigger than 1 or bigger than or equal to 1. Okay. Because for any value of omega, sin x omega is less than or equal to t when t is bigger than or equal to 1. So in this case, this is 1. So the analysis therefore boils down to just considering. So therefore now you can say let minus 1 less than t less than 1. Okay, and we need to compute fy of t for t in this range. Then so this is equal to so I'm not going to write each time the definition, but you understand. This is probability of the set of all omega such that sine x omega takes a value between, yeah, this is less than or equal to t. Yes, yeah, this is a set. So now you pause for a minute and then, okay, so this is some number which you may write sin x. So you analyze when is sin x less than or equal to t. And you are told that t is between here and here. And just, I'm going to draw some figure and explain this. So you draw the sine graph. Don't need to draw too much, but just some basic. Okay. So it vanished, and then let me just draw just a little more. This will do for me. So this is minus pi by 2 is 0, and it reaches its peak. It doesn't look perfect to me, but pi by 2, and then this is pi, and then this is 3 pi by 2, yeah, 3 pi by 2. It's enough for me to just look at this. And then you draw the line. So I'll draw it in red color. Okay. This line. What is this line? Sorry, it doesn't look like a straight line, but it is the line y equals t. Okay. So not to be confused with this little y here corresponding to capital Y. But anyway, this is, and you must look at what is the thing that contributes to sin x less than or equal to t. What are the values of x for which this happens? So that happens for this portion up till here. Okay, this part of the curve, you can even extend it all the way. Sorry, this is to be done in red. Ah, you can go up till here, and from here, sorry, now I draw it in green up till there. Okay, and then on this side, from here to here and up till here. Okay, now I'm not going to do all the thing, but what I'm going to say is, you just look at, first of all, you do this. I mean, usually you people know that you have to look at the principal value, do it for minus pi by 2 less than x less than or equal to t. So in this range, and then you take this in this range. So this implies sin x, or actually, so if t is between minus pi by 2, sorry, x between, yeah, pi by 2, you do this in this range. So this is equivalent to then saying sin x is less than or equal. There is some alpha here, that is what I meant, not t. But here is some alpha. So that alpha is that
So
unique
it's just the
number.
sine inverse t, right?
Yeah. So I'm going to write here alpha. Okay, sorry.
Sir, I was saying it was just sine inverse t, the alpha one.
Yes. Of course. Just write alpha here corresponding to this point. This is equal to, of course, sine inverse of t. I am reluctant to write it like this because you will see. Because it's multi-valued and I choose t in this range. What am I saying? T in this range. So here it's not t in this range. Yeah, sorry, I wrote something. T in this range. No. X is in this range. Sorry. Uh, Confusing. Yeah, x in this range. So this is in this case for x in this range, this is equivalent to less than or equal to t. But I can also look at the other side from here to here. Okay. This when I do that, where do I go from? So I go from pi minus alpha less than x. Maybe here I can allow equality, and then I say less than. Maybe where is I want equality allowed. This is I'm allowing equality here also. Okay, and this goes up to this point, which is 3 pi by 2. Okay, 3 pi by 2. For this also sin t, if only if for this range, you take this. So here, x in this interval. Okay, so the peak is pi by 2 to 3 pi by 2. I tell you why we need to do this, not just to look at only the principal value. So this one I will get here from here to here. Okay, so that portion, yeah, this also is equivalent to saying sin t, sin x is less than or equal to t. Okay, so minus 1 if you like, but that is obvious. Okay, so now then rest of the thing is just got by translating by 2 pi. That's all. So you just translate this portion by 2 pi and so on. And this portion also you translate by 2 pi and take union, and whatever that is, that gives you the probability. Therefore, so you need to write this thing very carefully. Okay. So Fy of t, I'm not going to write the full expression, but this is just to say that you can compute it. This is same thing as probability of. So I'm going to write here, just translate everything by 2 pi. So 2k pi, so union of Yeah, but then they are disjoint intervals, so it will become sum. 2k pi minus pi by 2 less than, so less than or equal to x, less than or equal to alpha, and sorry, alpha plus 2k pi. I forgot that other side also. Yeah, I translate everything. Plus 2k pi summation over k, and then plus summation over k again, 2k pi. So you just have to check that they are disjoint. That's the only thing that is involved. So maybe this point is repeated because I just translated, I get this one. So just to be cautious, I write here. I'm going to write here something. You will see that. Yeah. And likewise, it is enough if you should not include both the points. Okay. Only one of them you should include. And so because just so that the sets remain disjoint. Who knows, x could be a discrete random variable. We don't know anything about x. Okay, so this is plus, I had something, plus pi minus alpha less than x less than 2k pi, and then plus 3 pi by 2. And you check at home whether I have done this correctly. So of course you k varies in integers, k varies in integers. So you need to check that these two intervals are disjoint. See, the temptation is just like sine inverse and then look at the principal value and forget about the rest. But this, you draw the diagram, you see that there's part of this part also has to be captured, right? And this is not obtained by just translating by 2 pi. You see, if you translate by 2 pi, it will go to this side, somewhere far away, which I have not indicated. It will go here. Okay, so yeah, there you see, and you will capture this portion by translating this by 2 pi, but you will not capture this. So that's why you need to be careful. You have to draw the diagram in fairly sufficient range. Okay, so this is the only subtlety in the problem. I am just cautioning you. Just don't blindly write the sine inverse and then translate and you hope to get something correct. So that you have to be very careful. Yeah, that's it. I don't think I need to say anything more about this. Of course, you have to say here, if t is in which range? We already said that t has to be in the range here. So that I am not going to repeat. Okay, fine. Is this making sense for you? I hope. Okay, let's go on. Part C, I don't want to discuss in detail. You do it by yourself. Okay. Is there anything else I wanted to discuss? I don't know. Maybe I talk about the next topic. We will also do problems in that. Okay. The next topic also. This is random vectors. And their distribution functions. Okay, I wrote distributions, but better to write distribution functions. So next is topic. So this is something, random vector sounds rather abstract, but it's just that you may have more than one random variable and you may want to consider them together. Okay, and what you do is you make ordered pair out of it. So I'm going to say let formally omega f p be a probability space. Let yeah, so suppose x1, x2, xr, xn, all from omega, two real numbers be random variables. Okay. Then we obtain a function. We obtain a function. What is that? So x, you may want to underline it, but I don't want to underline it. No need to underline it. From omega to r power n. So what is r power n? It's just an n tuple of real numbers, right? And what is this function? What does it do to omega? Just puts these in order. So x1 omega, x2 omega, and so on, xn omega. And now you see this is a vector. You can think of this as a vector in Rn, right? So Rn is a vector space. So this is a vector in Rn. That is why now x is called a random vector. Random vector. I don't know why. I mean, if n is equal to 1, you will call it a x1. You don't call random scalar, you just call it random variable. But anyway, it's just called random vector. Yeah, it's just a fancy name for something that is very familiar, just an n tuple. That's it. Instead of taking values in R, it takes values in Rn. But the way I have defined it, it is automatic that this is actually a random vector. Okay. So more generally, what you can do is, slightly more generally, I can start with anything, omega to Rn, any function. So just corresponding to each omega, okay, I have here some, what is it, some vector here, x of omega. Okay. Of course, you need to make this hypothesis that this is this pulls back sets of the form product of intervals, two elements of script f. Okay. Then that's equivalent to saying, so such that let this be any function, any vector valued function, such that x inverse of, okay, some let me write here, set of all x is equal to x1. So I'll write it like this instead of writing things very complicated manner. I'll write like this. You write minus infinity a1 cross minus infinity a2 cross blah 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 cross minus infinity an. So this is a subset of Rn, correct? And this must be in F. You just demand it for all a1, a2, an. For all real numbers, a1, a2, blah blah blah, an in reals. Okay. Then x is a random vector. Is a random. Already we have defined what a random vector is, and in fact, x is equal to x1 blah blah blah. Sorry. Okay. It doesn't matter if the way I have defined it. I could, if you want, allow also this to be plus infinity. Okay. If you want, I mean, it doesn't really matter. Okay. Where? What is this xj? Xj is the composition So I'm just making things look a little abstract, but to R. So R power n to R, this is a projection, jth projection. Jth projection, this is X. That's the most natural thing. Of course it is. Is what? Of course. If at all it is a random vector, it can only be this. Now, why is it that some assumption here was needed? That is because X, each one of these Xj is a random variable. Yeah? Where this is a random variable. So this is a random variable. That see, only when you have these x1, xn random, or only when you are given that they are random variable, you can form this random vector. Here I didn't start with that. Okay, what's the difference between what I defined earlier and what is the fuss here about? The thing is, here you can always make this projection composition with the projection and call it xj, but xj must be a random variable. Meaning, if I take an interval xj inverse of something like this, minus infinity a, this must be in f, and this is guaranteed by this condition. Okay, this is in f. So I write here note. Okay, for all a in R. So this is what makes xj a random variable. You can always, given any function, compose with projection, you get another function, and then x is just, these xj's are coordinate functions. So x is equal to x1 blah 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 xn. But these are random variables precisely because you assume this. Now this condition you don't need to check here; it's automatic because you are already told x1 to xn are random variables. Anyway, so that's all I wanted to say. And now there are two things. X is called, so x from omega to r power n, a random vector, is called a discrete. If each xj is discrete. Equivalently, image of x is a countable set. So this is a bracket, is a countable set. Okay. And I'll define, okay, maybe I define continuous also. We say that, First, I want to define what is meant by distribution function. We say that, so fx, this is from where to where? Yeah, think for a minute. From Rn to 0, 1 is the joint distribution function of x, joint distribution function of x is equal to, you can say x1, blah, 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 xn, if the following holds. If, okay, so I could have said that this is fx is defined by the following thing, but if so, let me write that. F of fx of, now I'm going to write t, but it should be understood that t is a vector. Okay, t comes from again Rn, yeah. This is equal to probability of, I'm going to write x omega is less than or equal to t. Okay, now this requires an explanation. What do I mean by that? What is this? So this I should explain, because now both are vectors, you see. So I explained that here. So I should have said this first. Let me write it in green. Here we say that when, so you need to know how to compare two vectors. Yeah, we say that a1 an is less than or equal to b1 bn if aj is less than or equal to bj for all j. Mhm. Is this clear?
Yes, sir.
Sir,
Huh.
I think I missed something a little earlier. We said that like minus infinity comma ai, that whole
Yeah.
product needs to be in f, but f is a subset of the power set of omega. So how do we? Oh, x inverse. I'm sorry, sir. Yeah,
Inverse.
got it now. Yeah.
So
Sorry.
X inverse is a set, and that set must belong to F.
Yes,
Yeah?
sir. Yeah, got
Clear?
it now, sir.
Yeah.
Yes, sir. Thank you.
You're welcome. Yeah. So you see, this is a very funny relation. I mean, it's like you just understand it in the case of a plane, 3-dimensional, 4-dimensional, any other dimension is no different. So here, let me draw a picture of the plane. Then I just illustrate what is happening. So here you take 2 points. So maybe this looks like 1, 2. And then I take here, let us say, this is a point 3, comma, let us say something like half. Okay, these two are not comparable. One is bigger than or equal to, one is less than or equal to 3, but 2 is bigger than or equal to half. They are not comparable. Okay, so this is only a partial order. So let me say that this is a partial order. This is not a total order. It's not like this is only a partial order. Or I can say this is a partial order. Okay. So yeah, I want to write it in a different way also. Let me just 1 second, please. I want to keep that page. So what it means is that I want to rewrite it in a different way. Note. So this is yeah. So x omega less than or equal to t, this set of all omega such that this happens. Let us analyze this. This is same thing as saying that omega in omega such that xj omega, yes, is less than or equal to tj. So t is let t equals, if you want, we use always self-explanatory notation, otherwise takes too much time to say it. Okay. Okay. So now this must happen for every j. For every j. What does this mean? So this means that the jth coordinate is between minus infinity and tj. Tj is included. So this is nothing but set of all omega in omega. Omega in omega such that, so xj omega is in minus infinity to tj. This is it for all j. That is the set. Okay. So this is the set whose probability is that one. Okay. So let us just plot this. In that same example, just plain, and I take maybe this. So here, I should include Tj. Better make that very clear, because here Tj is included. So I put bracket like that. So suppose I choose 1, 2. So you draw this line. This is a line y equals 2. And now I draw this line. Yeah, it's very difficult to draw a vertical line. Horizontal line, at least one can manage. With vertical line on this Wacom board is near impossibility for me. I'll attempt at it. Okay, sorry. Here, just okay, you understand? No, this is a vertical line. Okay, and now what is a portion of the thing that is part of this? You just mark it in red, green color. This portion, this entire portion. And of course, these lines are also included. And that point is included, and this. Okay. So I drawn this as well as I could. So this is the picture that you get. Okay, this is a set, which is example. Yeah. Okay, fine. You understand. I'm not going to say too much. How am I doing in terms of time? Okay, fine. So when it is discrete, yeah, sorry. So suppose x. So you can do it for anything. Let's just do it for a dimensional thing. Is a discrete random vector or random variable, whatever it is. Okay. So suppose this is discrete, then we define the mass function, the what is called joint mass function. So you have to keep throwing in the word joint. Okay, joint mass function. Or joint probability mass function f of x would have as exactly as before, as so f of fx of, so here this time you write x, but x means a vector, mind you. This is equal to probability that x1 equals x1 blah blah blah, xn is equal to xn. Okay, so of course this is empty, or I mean probability of the empty set, which is 0 unless x is in the image of capital X. Okay, so I'm already telling you it is a discrete. Okay, so remember that. You can only have mass function for something that is discrete. And also here you can talk about mixed type of thing happening, and then x1 may be discrete, or x1 may be mixed, x2 may be mixed, all kinds of things can happen. I mean, it's just it's very complicated in general to talk about types and so on, but we single out one important thing. We say that x is continuous, x is continuous. Can't help my dog barking. It's in a different room, but even so, sorry about that. Can't help it. We say that it's continuous if there is a function which is integrable. Okay, let me first denote the domain and range from Rn to R, okay, which is integrable. So here, yeah, it takes actually non-negative values. Let's just put that integrable. I put it within quotes. It just simply means that you can integrate it over any reasonable set. Okay, product of product of intervals, for example, such that what is this f x of let me write here t if you like. Yeah, I want to avoid using t just at this context, so I write little x here is equal to, and now you have to write multiple integrals. I hope you have studied this. If you have not studied it, we will do it only for, anyway, most of the time we'll be doing it for 2 variables, maximum 3 variables. It really does. It's just iterated integrals, that's all. Okay. So f of t1 tn and then dt1 dtn, and then t1 is from minus infinity to x1. So t1 equals x1, blah blah blah. So minus infinity tn equals xn. And here, of course, minus infinity to xn minus 1. Let me write it briefly here because there is not enough space for me. Okay, so this is what it is. So it's like just like the one variable case. When you have one variable, you integrate over an interval. When you, and that too minus infinity to x1. So what are these x1, x2, blah blah blah? That comes from this. So here x is equal. Our notation is the same. I am not changing my notation. Xn. And what is t? Of course, t1, t2, these are variables. So you see, this t1, t2, tn, they vary in Rn. But the thing, range is restricted from minus infinity to x1, minus infinity to xn, blah, 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 minus infinity to xn minus 1, minus infinity to xn. We will do problems, of course. We are going to do it in a few minutes, couple of minutes. Just let me think if there is something that I need to say before I launch onto the problems. Yeah, I want to talk about this lemma. So properties, I want to say properties of fx. So assuming n, so I will write n x comma y, and then bracket I will say n equals 2. Instead of writing x1, x2, when there are only 2 variables involved, we write x comma y. And when there are 3 variables involved, we just write x, y, z. Okay, so of course, this is stated for n equals 2, but you have an analogous thing for any number of variables. Let us just stick to n equals 2 case for the sake of clarity. Number 1. Yeah. So yeah. So here x comma 1. So x comma y. Random variables. So this maps to R2. Okay. And now limit x goes to minus infinity. Y also goes to minus infinity of fxy. So let us just write properties of this is equal to f because I don't want to write each time the suffix x comma y. This is equal to 0. Because you want probability of the empty set to be 0, right? Limit, yeah, so x goes to plus infinity, y goes to plus infinity, fxy is equal to 1. And next property I have to write in the next page, unfortunately. Number 3, limit h going to 0 and k going to 0, f of going down to 0. So h and k are positives. Okay. So x plus h, y plus k. This is equal to f of x comma y. So for all x, y. And what else is there? I suppose that is it. Yeah. And okay. And one other property I want to state it separately. Limit y going to plus infinity of fxy. This is equal to, is actually a exercise, but let me state it all the same. But this time I emphasize my x because I'm going to write only one variable. Okay. So let us prove this. So do I need to prove these things? Do I need to prove these? Maybe I prove it because I don't want to leave it to chance completely everything. Let me at least prove part of it. So we will come to this property also, and I'll prove this. The problem is if I do go into the proof, there's not much time to do problems. Doesn't matter. Okay, it's all right. So let us prove number one. How do you prove number one? What is involved in the proof? So what does it mean to say this limit whatever, x goes to minus infinity, y goes to minus infinity, fx. So let xn go to minus infinity. So yn go to minus infinity. So let me not write this here. Let me write here. Then, okay, limit n goes to infinity. X and yn are arbitrary, and I compute this f of xn comma yn. This is equal to limit. Somewhere or other you have to unpack the definition. This is what, by definition, this is probability that x is less than or equal to xn, y is less than or equal to yn. Okay, and now let us denote this set. So I'll denote this by this set an, set of all omega, such that xn omega, sorry, x of omega, not xn omega, x of omega. Yeah, really sorry about this dogs barking. Is xn y of omega is less than or equal to yn. Okay, then this is equal to, okay, yeah, so it could very well be that xn and yn are not comparable. Xn comma yn is not comparable with x n plus 1, yn plus 1, but we don't care. You see, note that before I write the answer, note that intersection of, so limit n going to infinity of so these sets will have a, yeah, infinity, let me write that Pn, P of an is equal to, so you see these I can just write here. I can just, this is same thing as a probability of intersection of all these. And this is a crucial point. And intersection of all these is, of course, empty set, which is equal to 0. That's it. So this, I leave the verification to you. So you see, if I'm given, see, an, so it may be not the case that an is containing an plus 1. This may not happen. Okay, but if you go far down, there is a sequence, subsequence. So the right way to say that is that there is a subsequence. So there is a subsequence. So the explanation for this subsequence. So n1, n2, blah, 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 such that any am is contains some a and k for some k. This is very utterly trivial statement, but I want you to think about it and understand it after the lecture. And they are, what is nice about this a and 1, they are comparable. Okay. So, we know in the case of 2 dimensions, something like this will be the shape of the sets, and this can be some A1, this can be A2, and they are not comparable. But go further down deep, then they both become, they are both contained in here, something like this. So you choose your subsequence in such a way that, okay, this is achieved. Then limit, now it's clear, the limit that, this limit is in fact equal to limit here, n equals, all. You can write here with this notation, I can write nk and then put k here, and which is of course the empty set. Anyway, I have said enough, so think about it and then you will see. So proof for the other one is also more or less similar, and let's not worry. So what this is saying, this is just taking unions instead of intersections and writing a nested union. So you have sets where a and k is contained in a and k plus 1 and so on.
Sir,
And this,
do these 3 properties provide a characterization?
Yes, but sure, I definitely,
Okay.
yeah. Okay, so now let us do some problems involving these. How much time do I have? I have about 15 minutes. Yeah, before that, I want to say something about this one also. This one, probability of, let me come to this. So let me just call this maybe something properties. So I don't know. I think maybe just simpler to call it property 4. So just, okay, for 4, or proof of 4, observe that. Set of all omega such that x omega is less than or equal to x. Okay. This, what am I saying? This is same thing as limit y goes to infinity. Okay. So the second one, there is no restriction, right? Is equal to set of all omega such that x omega, y omega. You just keep track of this y omega. Yeah, this is less than or equal to, sorry. Hmm. So I want to write it like this. Just finish it off in one line. So n bigger than or equal to 1. So here I will write in brief notation omega. So x omega is less than or equal to x. Y omega is less than or equal to n. Okay, that's it. So how does that imply this one? So this I am not changing x. X is fixed. N is the one which is varying. But this is same thing as f. So sorry. Okay, so I should not write this here. Yeah. So probability of x omega less than or equal to x is equal to so okay, first I look at this one. So let us call this an. Okay, this is so this is union of all these things. So limit of probability of an as n goes to infinity. Okay, but this is same thing as limit n goes to infinity probability of sorry, not probability. This time I want to write everything in terms of f xy. Okay, so for clarity I write f xy and then write x here, allow n to vary, but this is same thing as limit n going to y going to infinity plus infinity fxy x comma y. That's exactly what we said. Okay, of course this side is just fx. That's it. That's all the proof is. Just very simple once you make this observation. Y is playing sort of a dummy role. So, but bring it in and then get rid of it. Okay. Now let us do a problem.
Sir, sorry, just before that, sir, a quick question. So those three properties, for them to be a characterization, would we also need like monotonicity? That fx
yeah, so yeah, I know. Okay, let me say this. That monotonicity, you cannot talk about. I think that is already said somewhere here. Let me say this. I think I wrote that somewhere. Property. Where is the property I wrote? Did I not write the property? I don't know where I wrote it. It's not that far. I left out one thing that is important. Did I not write that? Yeah, of course, I forgot to write that. That's so let me recall that zeroth property. So what is the zeroth property? F x. So this is a obvious one. Fx of x is less than or equal to, right here, x1. Fx of x1. So this I should have said that if x0 is less than or equal to x1, x0, x1. So this is, sorry, I should have said that at the beginning, but it's so obvious I forgot to mention it even, or vectors. So here if you are working with x comma y, so here write x0, y0. So, but it's true more generally in the context of, sorry about that, I should have said this. Yes. x naught, y naught. So is less than or equal to, so x1, y1. So x naught, y naught, x1, y1. So this I don't need to say in R2. I don't know if it is legible. Make that legible. Continue. If absolutely it is true. Yeah, in R2. Of course, this is very much required. Otherwise, you can just rather than sort of tell you only limit properties, but this is absolutely essential and it's rather trivial. But I was not thinking in terms of characterization, so I didn't pay attention to it. But true, of course, it is true. What else is there to say? Yeah. In terms of this one, if you want to characterize this, I suppose it's okay. This must be enough. Okay, fine. All right, so let us do some problem. I wanted to do some 3 problem, but let me at least do one problem. Example. So an urn contains so let me say 7 black balls. 7 black, 4 white. Let me say 6 red balls. Okay. So the experiment involves, so in an experiment, a ball is drawn. Color is noted. Drawn at random, it's understood. Color is noted. And replaced. This is repeated n times. N times. Okay. Now, so you can form a random variable. Let omega, okay, let me at least say what omega is. Omega be the set of, well, yeah, so you note down, no, why, so be the outcome. Set of all possible outcomes. What else can it be? Outcomes. Meaning which pattern appears and so on each time. Okay, so now you can form we have a random variable. We have random variables, okay, RVs. So which notes down the color of B, W, and R. Okay, B for black, W for white, and R for red. Okay, so random variables which keep track of. Oh, sorry. I don't know. Something happens and then it just starts scribbling. I hope it doesn't scribble now. Okay. Sorry about that. It's just something gets pressed inadvertently and then starts scribbling. Unintended marks. Okay. We have the random variables B, W, R, which count the number of the color, the number of balls of each color, the required color, corresponding color. Okay. So now let X be the random vector, B, W, R. Find the density function. Find the mass function because it's a discrete value. Mass function of X. Okay. So what do you have to do? You have to find probability that X is less than or X is equal to some X1, so some B, little w and R. Okay. This means what? This is probability that B equals B, W equals W, and R equals R. Okay. What is it? Okay. So out of how many balls you are drawing, see that number of times you are drawing, that is n, that is fixed, okay, at the moment. So we have fixed n. Each time there are 7 black balls, 4 white balls, 6 red balls. Okay. Okay. So out of the n, you draw, of course we must have, this is equal to 0 unless B plus R plus W is equal to, so 0 if B plus W plus R is not equal to n. Okay. And when it is equal to n, what is the probability? So let B plus W plus R equals n. So in this case, probability is, okay, so required probability B equals B, W equals W, and R equals R. So this is like, what is it that this is saying? What is the information you get out of the statement that the urn contains 7 black balls, 4 white balls, 6 red balls? Okay, that means total number of balls is equal to 11 plus 6, 17. And probability of drawing a black ball is 7 by 17. Probability of drawing a white ball is 4 by 17. And likewise, a red ball is 6 by 17. So these are the probabilities for each elementary event. And of course, it is understood that successive repetitions, the outcomes are independent of each other. Okay. So for elementary event, we know. And if it was only 2 things, it is binomial theorem, binomial distribution, you know that. But except that this time we have 3. And this is a good opportunity for me to talk about multinomial theorem. This is equal to, this is n factorial divided by, if you don't know this, I will explain this, but maybe a bit difficult to do it in just remaining, already time is up, but okay. No, 7 by, I think the total was 17 whole power B, and W, there were I think 4 balls, 4 by 17. This is B and not 6. This is W. And remaining, what is that remaining? 4 plus 7 is 11, 7, 6 by 17 whole power R. Okay. Now, let me say that this is the coefficient of x1, x power b, y power w, z power r in the expansion. Yeah, so I see. Yeah, so I must write here. I wrote it like this: 7 by 17 x plus 4 by 17 w. Oh, okay. So let me write here w corresponds to y plus 6 by 17 times z. So these x, y, z, they just keep track of how many black balls, how many whatever white balls, and how many red balls. Whole power n. So that's it. So when you expand it, so this is what you will get. So when you expand this, here you will have x, y, and 6z whole power r, but I am pulling out x power b, y power w, z power r. Anyway, you can think about this, and if you don't understand this, please ask the TS during the tutorial hour. I'm completely out of time, so I stop sharing screen. Okay, so see you on Monday.